All right, what's up everyone? This is Ryan here and we are at episode 13 of my live stream Q&A. So for this episode, I'm going to run through a couple of announcements, some mentions about Patreon, and I will be giving one short lesson, but we're going to focus quite a bit again for this episode on sort of more just answering high volume questions. What's up, Jatan? Good to see you, buddy. So let's just kind of dive right into the announcements. So first things first, I just wanted to thank my patrons. So far I've gotten 7 total, and I'm very grateful to everyone. I just wanted to read everyone's names out. So we have Mr. Bidwell, Tony Jones Jr., Elad Stavi, Trevor Halvorsen, Nanotech, Sushil Chanda, and Shadow. And so to all those people, thank you very much for supporting me. I greatly appreciate it. And of course, you are partly responsible for this lovely, nice monitor that I'm looking at on the right side here. So thank you so much. I probably won't be reading out all the patrons every episode, but I just wanted to make sure everyone gets mentioned here. And I might end up sort of doing like a reel at the end of the show or the start or something like that for patrons. But if I do end up getting more, then I could see this being a little bit of a bit of an operation to mention everyone. But anyways, once again, thank you so much. And that's it for that stuff. And for the next item, we're going to talk about some announcements. And I'm just going to make sure the sound is working and everything's all good. Oh yeah. Alrighty. Oh jeez. Looks like Chatan. So one of my friends from the stream in Wise and all that recently got a new job, and he's apparently having to work 14 hours a day, which is pretty intense. So I hope he's getting well paid for it. But anyways, so for announcements, we have a couple things here. So earlier last week, what I did was I released the first episode of my roadmap series. So basically the idea there is I was thinking about doing this for quite a long time, but then I actually got asked directly by a viewer if I could do something like this. So the first part of my roadmap series is already up, and that's directed towards people who are like absolute beginners of Android, like you've barely opened Android Studio kind of stuff. And so that's a roadmap series for beginners, I believe it's called. And I'm working on part 2, which will be directed towards Android developers. So the first one was basically, whoa, my monitor just died. What the hell? There we go. Sorry. The first one was basically how do you like just even get to the point where you set up Android Studio and you can deploy an application, and how's that kind of work? And then for the junior roadmap series video, it's going to be sort of how do you build a basic application? So we're not going to go crazy into like building, the clean architecture, full stack kind of crap, but how do you get like a basic application running that you can like upload to GitHub and potentially get some work or get a job from it or something like that? So anyways, watch out for that next week. And I also have a room database sample coming out next week. The code's about 50% done, and it will be a full app tutorial. But what I'll do is it actually kind of starts from the RecyclerView 2017 full app, that repository. So I'm kind of like taking that repository and using it as the starting point, and then I'll kind of build the room database from there. And I figured that would just be a lot easier than having to build a whole nother app from scratch. So watch out for that this week. And if you're not familiar about what I'm talking about, Room Persistence Library is part of the Android architecture components, which was mentioned in or released in Google I/O 2017. It looks super awesome. It's a database library, and you can basically use it to interact with an SQL database and using annotations. So it's kind of an annotation-based library, and it just looks pretty awesome. Anyways, I'll shut up about that. And the last announcement is what I'm going to be calling 5 days of solid software architecture principles. So in the previous episode, I got a question from a viewer, which I don't remember exactly what it was, but it was along the lines of, can you talk about solid principles? Now, the thing about that is like, A, I'm really bad at remembering names and things like that, and B, I don't actually, uh, let me just put it this way, I don't memorize like each of the solid principles off the top of my head. Like, I'll try now: single responsibility principle, open close principle, Liskov substitution principle. Yeah, that's as far as I get for now. But what I'm going to do is, a lot of these things I apply in my code and I don't necessarily remember the words for it. So what I'll be doing is, for each episode of this stream at the beginning, I'll go through one part of that acronym. And so that will actually kick off our short little lesson for today. And then we'll just jump right into viewer questions after that. So also, you'll notice I've kind of played around with my overlays a little bit for the stream so that they're a little bit less obtrusive. But yeah, so to kick off with solid architecture, so solid brah. So solid lesson number 1. And the first lesson is going to be on the single responsibility principle. So just really quickly before I proceed, what are solid principles? So it has to do with a bunch of really awesome programmers and software architects kind of coming together, and some people are quite famous. Unfortunately, I forget the name of the individual who actually created the SOLID acronym, but if you've heard of the name Robert C. Martin, he talks about solid principles all the time. And they're basically ways in which you can build object-oriented programs in a way that sort of, without getting really, really deep into it, the way you build these things, if you do it intelligently, can help you solve problems down the road, and it can actually eliminate problems that you would have to otherwise deal with if you just built like crappy God activity spaghetti code applications, which are impossible to maintain. So the first principle we'll be talking about, and I hear the garbage truck outside, so I'm just going to close the window. That garbage truck. And so the first one is going to be the single responsibility principle, and I've just got a quick little bunch of notes here to go over. So, what is the single responsibility principle? So to kind of give my own rehash, I would encourage you to look up other definitions, but here's kind of my vague definition for it. So, and let me just make sure that, yep, okay. So basically what it is this is kind of my definition. Each module or class should generally be responsible for doing one thing. So there's more technical definitions. So your first question, if you're a beginner, might be, well, what the hell is a module? What's a class? My suggestion is, so for module, I want you to kind of think of maybe like a whole package or a whole layer of an application. So for example, let's say I'm building like a fairly classic three-tier software architecture where you've got like the presentation layer, maybe the business logic, and then like the data logic, or whatever words you want to use. So in that case, you've got like the user interface as a single responsibility, and then you've got like maybe the application's logic, and then like the data logic, and those are module level single responsibilities. However, we can get more specific. So we can have specific classes or specific files, and what we'll find is those should generally only do one thing. So that's probably kind of vague to beginners. So what I wanted to do is kind of bring this into an analogy which I like to use. So for the first example, let me just catch up on my notes here. So for the first example, I wanted to talk about So I want you to kind of imagine we are building architects. We're designing a house or something like that, or an apartment. It doesn't really matter too much. Now, how can we kind of think of something that's analogous to software architecture but is a lot easier to think about? Well, let's say we're designing a house and you want to build a module called a kitchen. And this kitchen, its responsibility is managing food. So that's the first thing. So we've got this sort of module kitchen. Let's kind of pretend it's part of our app if you want to. And then within that kitchen, you're going to have classes, or you're going to have appliances which have more specific functions. So for example, we've got maybe a fridge or a class, and its job, store food at a desired cold temperature. Or we've got a class oven. Its job is heat food up to the desired temperature. So the point I'm trying to get at here is I don't want you to go too crazy with the single responsibility thing. Like, the responsibilities themselves can be quite broad. Like, for example, if I was building a view, like a fragment or something, I wouldn't necessarily say one fragment to set the text of one text view, but I would say the responsibility is like UI stuff. So that's the main thing. So why is that kind of important? What does that actually do? Well, there's a couple things, but one of the most important things that the single responsibility principle provides you with is it does a whole bunch of things. It makes things easier to test. It allows you to draw like logical conclusions about where different pieces of your implementation, and I'll explain what that is in a bit, should go in terms of which class. It allows you to sort of think, okay, does this make sense to put this implementation or this responsibility here in this class? Should I pull it out into a different class? Should it be in a different layer? So what do I mean by implementation? I mean the code, the actual code necessary to fulfill the responsibility. So for example, for the user interface, the implementation in the user interface would be like, find view by ID, setting IDs, and then view.setText. So that's implementation stuff. So why was I kind of saying that we can draw logical conclusions? Well, to go back to our sort of kitchen analogy, I have to ask you, let's say you're designing a house. Does it make sense, if you're designing a kitchen, to put a toilet 2 feet above your stove or your oven? Does that make sense? Would it make sense to put a bedroom in their class? Like, would you just stuff this one friggin' room full of everything and then leave the rest of your architecture just ambiguous and barren? No, it doesn't. In the context of building architecture, for the most part, it makes sense for a kitchen to have a sink, an oven, blah, blah, blah. It makes sense for a bedroom to have a bed, maybe chairs, whatever. It doesn't matter. The point being, that's where the conclusions can come from. If you give a module or a class a single responsibility, then whatever you put in there either pretty much belongs or it doesn't. So that's kind of the important thing. So the last thing that I'll say, let's see what my next thing is here. So the last example I'll talk about, and then we'll get into viewer questions, has to do with how we can apply the single responsibility less analogously, just more directly in the context of like a ModelViewPresenter software architecture. I realize some of this might be slightly off screen, so I'll try and, or my face might be blocking some of it. Let's try and fix that. So for the second example, if you're not familiar with ModelViewPresenter, just in a nutshell, it's too difficult to summarize in like a minute, but the model kind of represents and provides access to structured data. The view interacts with the user by drawing the user interface, and listening for UI events, although it should basically just forward those events to the presenter. It shouldn't really deal with them. And the presenter is responsible for kind of communicating and coordinating with other layers. So as you can see, each of these layers or modules or whatever friggin' word you want to call it, they have kind of a broad responsibility. And what that can do is, just in the context of like object-oriented programming, we can, and if we combine the single responsibility principle and we follow it well, and we structure our application with an architecture, and we use objects or even just like events or things like that to represent our data, then we get this really neat scenario where, let's say for example, where is my phone? What our applications start to look like is, if I just pull up a random application here. So let's do pause trainer. So for example, when I press, I'll press the plus button, and that's going to trigger a UI event in the view. The view is going to forward that. Its responsibility is just to forward the event, so it's going to forward that to the presenter. The presenter is going to decide what to do with it, and it's going to say, okay, the user wants to build or add a new alarm. Hey model, add a new alarm. The model's going to do its thing, and then and then it's going to either respond to the presenter, it's going to call back or whatever. It's going to call back, and then it's going to either say fail or success or whatever, and then that result the presenter is going to get, and it's going to pass it into the view. So what I'm trying to demonstrate here is, like, basically if you give things good responsibilities and you follow good object-oriented principles and you have a proper software architecture, the flow of your application becomes super testable, because you've separated everything out into like module, so you can run tests. So let's say I'm testing the middle part of my architecture. I can fake this part, fake that part if I need to. I can just test this part in isolation. So, and there is a text. So that's basically it for single responsibility principle, and hopefully I'm kind of giving you some insight into how you can start thinking about software architecture. Also, for the beginners out there, if there's anything I mentioned in here that doesn't really make a lot of sense, please ask me to clarify it. I'd be happy to talk about it, because this stuff is super important. So I've babbled for nearly 20 minutes, so I think that'll be it for my lesson for today, and we'll just jump into viewer questions. And I'll just run a quick commercial break. Give my cracking voice a rest. And if you've enjoyed the show so far, do me a favor and hit the like button down below, or don't. Sorry, I'm getting messages from my friend who is currently in northern BC fighting fires because we're having kind of a forest fire epidemic here in British Columbia, Canada. So hopefully he's being safe, but he's not happy about being up in a random little town. But good on him for going out there and saving lives and homes and things like that. Anyways, so let's get caught up here. So Mr. Rainmaker is asking about ProGuard. Unfortunately, I don't understand the deeper nuances of it. ProGuard is, I'm not sure if you would call it a plugin, so to speak, for Gradle, but it has to do with, I believe, code obfuscation or security. So I know that, like, just the surface level it, but I couldn't really give you a detailed answer on that. Hey, we've got a couple people here. All right. So it looks like no, it's interesting. When Bassam is mentioning that Lego is a good analogy for software, I the thing about software for me is that as I mentioned endlessly, I'm a super visual thinker. So when I'm explaining software architecture stuff, what I'm basically doing is visualizing it in my head and kind of describing that picture. So if you're and that was really when software architecture and programming started to actually become interesting to me because for me, I have a lot of trouble with rote memorization and I have trouble memorizing like words. So, for example, if you asked me to write an enhanced for loop, I know what a for loop is. Or an enhanced for loop. I've written at least 50 of them, but a lot of times I will forget the order because my brain doesn't remember like a words of a programming statement. However, when it comes to software architecture, that's my friggin' game because I can visualize it and visualize like different parts of the app talking to each other, and it becomes a lot more interesting for me. And when things are more interesting, they're easier to learn, of course. Anyways, so my friend Chetan, who is the fellow who he's got a new job and he's working 14 hours a day, has mentioned that he has no social life left. I feel you, man. The life of a programmer can be very lonely, but I think you've got this. And you know what? If you start hating it, then you can always quit. But yeah, good on you. Work hard, bro. I know you got this. So, let's see here. Okay, here's a great question. Okay, so this is from, let me just pull up my sheet here. So, this is from, I'm trying to think of where your name's from. Looks vaguely Eastern European or something. Vladan. Vladan asked question. He doesn't actually, I don't know if he actually sounds like that, but. So Vladan's question is, what should your portfolio look like when you want to start applying to Android developer positions? And am I in webcam mode? I totally am. Let's go back to that. So what should your portfolio look like when you start applying to Android developer positions? So I'm going to assume that you're applying as a junior developer. My answer would change depending on like what level of position you're applying to, but so like as a junior, we'll say i.e. as a junior developer, what should you be expected to know and have in order to get hired? So the main thing, there's a couple different things here. So the way that I kind of approach job applications, and I've done quite a few over the years, is you want to always, so you're gonna sort of, let's say you're looking at a job application, you're gonna get a list of things that the developer is looking for. So most importantly, most companies will give you kind of a hint as to what technologies they use. And that'll usually be in like either the basic requirements or the would be nice to have requirements kind of thing. Like if you're looking at an actual job application, so you should know, REST architecture, you'll see that on almost everything. You should know object-oriented programming, that kind of stuff. So the first thing is that, so the main thing is, number one, if you're applying to a company, get an idea of what technologies they use and have a look at their applications. So that's the main thing. Do a quick reconnaissance. You're not going to be expected to like be an expert in every app they've ever released, or if they've only released like one primary app, you'll probably want to become quite familiar with it. So that's the first thing. Now, why do you do that? It's your cheat sheet. You kind of figure out, okay, this is what the developer is looking at. So, but what should the portfolio look like? Well, let's say I look at a company and I notice, for example, they really like, sorry, my voice cracking is bad today. Let's say you're looking at a company and they're really big into RxJava and all the RxJava libraries. This is kind of a poor example for a junior developer, but just run with it. So doesn't actually matter what the actual technology is. So you figured out from your reconnaissance that they want RxJava. What I would suggest you do is, at the minimum, have one application viewable on GitHub, which you can link the employer to. So as a junior developer, and this is totally an opinion piece, I'm not a hiring manager, blah, blah, blah. I've been through a number of Android developer interviews and particularly junior developer interviews. But the main thing is have at least one application that works. It should compile. It doesn't need to be very complicated. If you can, deploy it to the App Store. That's also a bonus. And it doesn't need to do anything or have lots of downloads. You're just demonstrating that you have uploaded something to the Play Store. So that's the first thing. Have one application. For bonus points, this app should use some technology which is either an industry standard or a technology which you've observed the company uses. That's kind of a broken English sentence, but I'm not going to try and fix it. So either A, it should use industry standard technologies, your app, at least one. So let's say you've got a note-taking app, which would be a great idea. Use an actual database, like whether you're using Room Persistence Library, you're using Realm, you're using SQL Bright, use an actual kind of industry standard library. That's really important because employers, here's why, and this is the big takeaway here. And this is, excuse me, I did really well in my last series of interviews, my last application process, because I had built Profiler, which unfortunately it's 6 months old now almost, and it needs extensive overhaul. But at the time, I had built an app which used RxJava, it used Firebase, it used Mockito, test-driven development. It used a whole bunch of sort of industry standard practices, and all of it was open source. So I walked up to this company and was like, hey, I don't have a degree, but if you want to know how good I am at coding, here is all these technologies I use. Why is that valuable to the employer? That tells them two things. Number one, you're good at learning, most likely. That'll tell them. Number one. Number two is that if you happen to know how to use technologies their team already uses, that is way less investment in time, and that's a major bonus for you as an application. So to wrap this question up, what should the portfolio look like? So I tried to give you some hints for building it. Have at least one small to medium-sized application which uses a couple nice libraries. You can use the framework libraries for Android, or you can use third-party. If you can get a sense of, if you are trying to get hired at a specific company, figure out what they do. Look at their app and don't try to, especially if you're a junior developer, don't try to build it like way better than them. Just look at their app and know, like, okay, they like to really follow material design, or they like to do this kind of thing in their app. And like, don't carbon copy it, but kind of apply the same principles. And have that on an open source GitHub repository. Try and publish the app to the Play Store. And beyond that, you're not really going to be expected to know much more than that. It'll depend on the company, but to me, that is the definition of a junior developer pretty much, is someone who can build a basic functioning app and deploy it to the Google Play Store. So that's basically it for Portflio. Hopefully that helps. Also, if you want to do social media stuff, like in your repository project, do a nice README, do screenshots. Check out pretty much any of my repositories, but check out PostTrainer down below, and you'll see I've got screenshots, I've got sections. All of this is just really nice for employers to see. So that's basically it for that question. Let's see what else. Oh yeah, and this is something that Chetan mentions, and you'll get this in almost every friggin' job application. It's really important to learn how to use REST, R-E-S-T, and basically, really quickly in a nutshell, you're either going to want to use Volley, V-O-L-L-E-Y, or you can use Retrofit. I believe something like 80% of companies use Retrofit, and so these are both REST libraries, and how that kind of works is using either Volley or Retrofit. I'll just say Retrofit for simplicity's sake, and that's the one I personally use. If you add Retrofit as a library to your project, so you've got your app, let's say you have a REST endpoint or a web server. REST allows you to talk to that using HTTP requests, which is just a way of talking that is common to a whole bunch of different things. So if you don't get like super wrapped up in what is REST, what does that mean? Just understand REST is one way, it's the kind of the industry standard way to talk to a web service pretty much. But whether you're talking from an iOS app or an Android app or whatever, but the point is you're communicating with the same communication channel. I would strongly suggest Retrofit with OKHTTP for that. If you include a small app that does that, and you can find like a test, you can find like a fake REST endpoint that gives you data, or you could use like the Wikipedia REST thing to download Wikipedia data. GitHub has like a REST endpoint, I believe, you can use to just parse data from GitHub. Do a little app that does something like that. That'll really help you out. Thank you, Chetan. That's a very good point. Okay, so sorry, lots of questions. I'm finding difficulty. Okay. I see Ian Hunt found my, I normally try to crack jokes when my voice cracks because you kind of got to play it off. There's no other way. And yeah, I'm glad my voice cracking is amusing to people. Okay, so this is kind of an interesting question. No, stop it. I'm just gonna do the rest of the stream like this, I guess. Okay. So this question, this is kind of an older question, but so Bassam, sorry, I will switch to code here. So Bassam asks, oops. Do I use UML and also kind of even in my head? So this is just kind of a fascinating question. Let's pull out the old notes. See if I can find something relatively quickly. Oh, let's just use the old friggin' the de facto Ryan's software architecture diagram here. Here we go. That'll be a little more straightforward. So let's talk about just briefly, like, first thing, so this, I'm kind of making a question out of this, but I feel like it. So what is UML? Just for beginners out there. So that stands for Unified Markup Language. So whatever, it's actually not very unified in my opinion, but that's totally fine. So this book is called, where's my mouse? This book is called Design Patterns Explained by Alan Shalloway and James R. Trott. And it explains UML really well, but let me just show you a quick picture here. Okay, so the thing about UML is that there's so many, I don't know, maybe I'm saying something that's incorrect, and maybe some computer science people would say that there's like one thing is UML, but let me talk about how I think of UML and how I apply it. So like proper UML might look something like that. Oh, come on, focus. So you've got classes, shape, point, line, square, and then these lines and the particular kinds of arrows mean specific things. So like, it doesn't want to focus, but yeah, so like, I'll switch to my diagram now. So now this is not proper UML, but for example, if I'm being intelligent, I'm saying that like this kind of arrow means uses, this kind of arrow has like a these things compose of the activity, just blah, 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 a bunch of technical words. So what is this actually, how is UML useful and what does it mean? So in a nutshell, the way I think of UML is that it's one way to represent the architecture of your application at a high level. So, excuse me. So the way, when I first started coding, it was horrible because I had no way of kind of visually representing my code, or I was pretty bad at doing that. And eventually I figured out that it's very easy to represent your code in diagrams and visual stuff. Now, you might not be a super visual learner like I am or whatever, but so for example, what I have up here, this is probably not what purists would call UML, but this is what I would call UML. It's an architecture diagram. And what I'll just say is that, for example, let's say I've got this application class, which is the container for the activity, which is a container for a view and the presenter, and these two things talk to the view model. Sorry, the presenter talks to the view model, gives that data back to the fragment. Then I have my use case layer, which the presenter talks to through an interface, and then my interactors talk to my service or data layer through an interface. And then we've got Dagger, what I call the Dagger 2 dependency injection layer out here. So I'm showing you all these different lines and boxes, and they all have names, and what does this mean? This diagram is very closely representative representative? Is that a word? It is now. Representative of my software architecture, for example, in PosTrainer. So let's open up PosTrainer, and you'll notice there's a use case or domain layer, just like that. There's a data layer or service layer, whatever. There's a Dagger 2 dependency injection layer. So just to wrap it up, the point is that this stuff all is one way of representing a software application or the architecture. So do I use it? Yes. So before, well, I won't like do UML for every application, but let's say I want to figure out how would I like, let's say I was learning a new software architecture style. That would be when I would want to make one of these big diagrams. This is actually clean architecture with passive view for the presentation layer, if you want to get really wordy and technical. So I drew this diagram so that I could understand and visually represent clean architecture and all that stuff. Now, for me, because I'm really visual, do I do UML in my head, so to speak? Not 2D visual like this so much. It's really hard to describe. But I kind of, in a sense, I do represent the architecture in my head. Anyways, I'll leave that question off there. But I do use UML, and I do represent architecture in my head. But a precursor to that step will be drawing things on paper. And then once I've got it on paper, then usually I can kind of make a picture up here, and then I don't really need to look at the paper much again. So that's that for that question. Sorry if that was kind of random and tangential, but I think usually my stuff's pretty random and tangential. Okay. What else have we got? This is a fairly straightforward technical question. So this question was Mr. Rainmaker. Whoa. Mr. Rainmaker. Or do you capitalize the M? I always screw that up. So used to camel case. Mr. Rainmaker asks, how to avoid leaks when using AsyncTask. So, the silly but really practical answer I would give you is don't use AsyncTask. Learn how to use RxJava or learn how to use live data, but because AsyncTask, it's kind of archaic. But what is an AsyncTask really quickly? So an AsyncTask is an operation which you can direct to be performed on a background thread and return the result of that data on the UI thread. So that's kind of what an AsyncTask is. Let me just pull up some code and we'll have a quick look at this. Let's hope I have some code handy that still uses AsyncTask. Just while I'm pulling this up, the reason why I said use live data or RxJava is because you can do whatever you want to do with an AsyncTask, except better, kind of, if you're using other options. But AsyncTask, it's quick and easy to get going, so I don't really hate it. I just wouldn't suggest it for like production applications. Okay, so this is really old code. So just understand that. I'm not saying this is the way you should do this, but in the first application I ever built was called Catalyst. And the way that I interacted with my database is I gave each operation to the database a specific async task. And how these things kind of work is you can give them, let me zoom way the hell in, sorry. You can give them like parameters. And basically what the parameters are the types. So this is the type that you pass in. I kind of forget what the middle one is, but this type over here is the return type, which gets posted back to the main thread. So what does this all mean? How an async task works is you can, if you like, start it with some parameters in background. You give it something, and then this is so this is like your initialization. Wait, I think I messed this up. So you create it, and then this do in background is basically you slap code in here which you want to be run on a background thread, and then once it finishes, when return params gets called, it's going to jump into this onPostExecute method. And this onPostExecute method is a callback to the main thread or the UI thread or whatever you want to say. So why is this important? Basically, you don't want to do background operations or long-running operations on the main thread. So you offload that code, that data to the background. Once it's finished, you want to call back on the main thread or the UI thread. And I believe if you don't call back to the UI thread, the UI won't be updated or something funky happens, but I can't remember exactly. Now, what is the problem with AsyncTask? Let's go to the, I wonder what, let's see if I can find something that uses this. I haven't looked at this code in like a year, so you'll have to bear with me here. Activity history. See if I can find a... Okay, so I've got one of my async tasks here, read from database. And so I set its arguments, and then I get it going. I set a listener, and then I call execute, and we start the async task. So why is this an issue? Why did people crap on async task before? Well, let's just say I'm going to copy that. And then I'm actually going to go back to the, where is that one? Read from database. So let's say, for example, this activity starts. Where is that method? So this activity starts, and then it starts doing its operation. It starts reading the database for exercises. Then the user tilts the phone and destroys the activity. So this activity, this current instance of it, gets destroyed. However, since this thing's running in the background, this async task, it's going to keep going, and it holds reference to an activity which is now null. It's been destroyed. So if you were to tilt the phone as this query was executing, it would call back in onPostExecute, and this callback would throw, I believe, a null pointer exception, because the thing it's calling back to, that reference is now non-existent, and we have a new activity. And then we might have a situation where we've got another new async task up running. You've got your old async task still doing its thing or trying to call back to a dead activity, and you can see where this could be an issue. How do we avoid these kinds of scenarios? My suggestion, honestly, would be to just, okay, there's two quick ways. If you really want to use AsyncTask, the only thing I would suggest that's remotely feasible is run the AsyncTasks in a headless fragment that has set retain instance set to true. And you're going to need to make sure you manage that fragment and its lifecycle really well, but that's the key point, because if you run the AsyncTasks in the fragment, even if you destroy the activity, in most cases, your fragment will continue to exist, and your AsyncTask can call back to that fine, and it's not really an issue. So that's like the practical thing. However, I would just suggest in general you don't use AsyncTask anymore. Look into live data from Android architecture components, or look into RxJava, because they're both way better solutions to the problem. AsyncTask is really simple, but with simplicity comes, with simplicity and a lack of configurability, I'm making up all kinds of words, there are costs to that. So hopefully that kind of answers your question. Set retain put the AsyncTask in a fragment, set retain instance, and fire it from there. Don't have it call back to the activity. I did see one other hacky way that someone had, which was to like put some code. I think they like passed in the activity itself as a member variable and then just null checked it before calling back. But that's like I don't like that solution at all. That's ugly. So yeah, hopefully that answers the question. All right, I'm just going to run a quick commercial break, and we will carry on. Yeah. Yep. Daryl Bitsy mentioned still talking about AsyncTask in 2017. That's right. Well, you know, I got asked a question, and all right, so I'm probably only going to do one or two more questions. Okay. So Daryl is asking about the difference between MVP and MVI. I haven't actually looked at MVI, which I believe is model view intent, so I can't actually answer that question. But I'll look into that for next episode, because I am curious about model view intent. But the main thing is, like, I haven't started a project yet which uses it, so I don't like to discuss things until I've worked it into the code itself. But I've heard a lot of mentioning of model view intent, but I don't really know much about it. I do know that it the first time I read it, I thought that it like was an architecture which used the class intent a whole bunch, which I just flat out knew was a bad idea. But it turns out actually that's not. Intent doesn't mean the class intent, it means something else, which I'm happy to hear. And the reason about the intent class itself is I remember reading that if you leverage or if you use too many intents, I believe because it's something that uses system resources or some crap, if you use too many intents in your app, and by too many I mean a lot, like some of them can start to get garbage collected or something like that, or dropped. Anyways, but that's not what model view intent is. Yeah, thanks for stopping by, Vladan. YouTube tips. I don't know. I'll give YouTube tips another time. Oh, that's a good question. How do you deal with Orientation changes. I don't know if I'll answer that today, Ian, but that is a very important question. Let me just look through the questions. I might come back to dealing with orientation changes, but let's see here. My brain's tiring up a little bit. Okay. So this question is from Salman, and his question is, so I suggested as a good first decent sized app that you build it with an SQL database. Maybe you might have been watching one of my older videos, but or you can also use a Realm database. Salman is asking, like, kind of where do I, so once you've got a basic app which uses a database, like a to-do app, where should you go from there? Like, what's kind of the next step? So let's say you're up to junior developer. You've built an app with a database. Where do you kind of go from there to almost get into being an intermediate Android developer, which is kind of where I consider myself to be? My suggestion for that, Salman, would be to build an application which leverages a web service. So I would suggest one of two routes. You could use either have it talk to a REST service using Retrofit or Volley, or you could also use something like Firebase. If you really want to learn it deeply, you'll probably want to go the REST route, but you can also, Firebase isn't bad. And what I would suggest to you is build something similar to like my Profiler repository. So, and this is an open source repository. Now, before I continue, this project is old. I need to update it drastically. But the basic gist of it is it's an app which talks to, it's got quite a number of features. Like it's got, let's see here. It's got 1, 2, 3, 4, 5, 6 different app features or activities. And it has login authentication management. It talks to Facebook. It talks to Firebase. The key point I'm trying to get at is build like a medium scale app that deals with network issues, that if you really want to go like hardcore, make it have like a remote data store and a local data store, so that, for example, when your app is offline, it still has some cached local data that it can display to the user. Challenge yourself. For your next project, after you've got like the basic one, jump into RxJava or something like that. Challenge yourself. Build some complicated industry standard technologies. So I'm thinking Dagger 2. Challenge the fuck out of yourself, excuse my language, and you will grow immensely from that. It may take months, but that is how you really take it up to the next level. And once you're done doing that, if you want, you could try and upload that app to the Play Store, or you could make it open source. This was the app, Profiler, which was like my main repository at the last place that I applied at. And this was the one that made them kind of see, okay, well, this is, it's not the best app, but this is okay. Definitely not a junior developer anymore. So hopefully that kind of vaguely answers your question. Build something which uses REST, I would say, and build a decent scale application. All right, let's see. Yeah. Let's do one more question. It can be kind of off topic if you like. I'm not going to do another big question, but let's just I'm just going to take one quick break here, and then we'll do one more question. One thing I don't, this isn't a question, but I don't really agree with you, Bassam, about keeping your app portrait only. I actually agree that that is kind of a hacky way of solving the problem. I understand where you're coming from. Bassam is basically saying almost no one uses portrait and landscape, and you just hop into your Android manifest and set portrait only, whatever that setting is. I understand that side of the argument, and also, like, to a degree, even certain parts of my application, like for example, the one part of Pos Trainer which actually does have the actually no, it doesn't anymore. Never mind. There are certain use cases for restricting the orientation. So for example, obviously if you're like designing a game that's meant to be played in a certain mode, obviously you're going to want to restrict. Like, restricting the portrait is not like a sin of all sins. However, like, it does depend on the use case of your application, but if you're doing it as sort of a thing to just like, oh, I don't really want to deal with this, I don't want to learn how to deal with orientation changes, my approach is always I want to build the best application possible within reason, and to me that includes, allowing for scenarios like, for example, if someone's got, like, they're driving around in their car and they've got a horizontal phone dock and they want to be able to use your app in landscape mode, like, don't go crazy with it, but if you're not handling landscape at all, I think that's mediocre. But that's just my opinion. Maybe other more experienced developers have a different opinion. I do not watch Simple Programmer. All right, well, I think I'll call it. Let's wrap it up for today. Nothing against Simple Programmer. As a general rule, I don't actually watch other YouTubers that are programmers. I'll watch presentations by programmers, but as far as like dedicated YouTube tutorial people, I don't watch them, and there's two reasons for that. But most importantly is I always want my content to be straight from me as much as possible. Obviously, I learn from amazing developers like Robert Martin, Martin Fowler, Don Felker, Kaushik Gopal, those two guys from Fragmented. I learn from Jake Wharton, Jesse Wilson, Florina Montanescu from the Android. Come on, brain. Android Architecture Blueprints repository. This guy, what was his name? Wasn't Javier Reyes? I don't know. I forget. He did this Android 10 clean architecture library. Anyways, the point being, I don't actually watch other YouTubers, and I won't. And it's not because I think less of them, it's because I don't want cross-pollination with my content and their content. And also, what other people do doesn't really concern me that much. And that's just been a key factor in my life, is like really not giving a shit too much about what other people do and what they think of me, within reason. Anyways, that's all for now. Thank you so much for watching. It's been a fun episode, and we will see you next week for another session. And in the next session, we will talk about the open-closed principle, which is the second part of solid architecture, or solid architecture. Yeah, solid architecture principles. And that's everything for now. Thank you so much, and watch out for more content and videos coming out this week. Peace out.